Hi, in this video I want to show you how to switch a Linux virtual machine from EXT4 file system to root on the ZFS file system without any out-of-band help. This particular machine will use Debian 12 Bookworm. So this tutorial is based on this tutorial written on the ZFS main page. However, we will not use any live CD or DVD, but we will use a VM, a virtual machine that is normally provided from a cloud provider or your enterprise IT department. For that, I will create a virtual machine with a Hetzner provider and show everything as it goes. So I will add a new server. I will add it in Germany. I will select the Debian operating system in the current version 12, that is Bookworm. And so it goes all smoothly. We will select a slightly bigger machine with 2 cores and more gigabytes of RAM. I want to access the machine over IPv4. However, if you have IPv6 connectivity, you can select that as well. I will leave both on. I will select a personal key, SSH key for secure authentication, and I will finish with choosing a different name. That will be example EXT4ZFS. And I will create this machine. In a moment, the machine will be available. At this point in time, I can click it and select the addresses. So just by clicking, I will copy this address, and I have a prepared configuration to the side where I will exchange this address. This machine should be available now. So with that out of the way, I can switch to SSH. I will ping the IP address that was provided to me. It seems the machine is online. Now I can extend my SSH configuration by attaching a separate file. This can be done in this manner. I don't want to show you my SSH configuration, so I can include a separate file that will include the SSH configuration just for this tutorial. So I have prepared the configuration on the side, and that will be this. So I will just use a here doc to include this short sample, and I just hit enter. I can list the file. Okay, it includes what I have written. So I can connect to this host, and now I can compare the fingerprints. I will show you in a moment how to do that. To the side, I will just compare the fingerprints on my own. And I believe that is the correct fingerprint. So I will type yes and continue. Okay, I will have to input my password. For that, I need on the side to get it from my password manager. which I'll do. Okay. I will not connect using the password here. So again, I put in the password and now the key is unlocked and everything went smoothly. So I'm connected. The machine is now available, has these following addresses, everything is fine. So we will continue with the tutorial. So I'm now connected to the machine and I will list the hard drives, how the partition layout works out. Okay. So the idea here is basically that I will, from this operating system, I will first shrink the EXT4 file system to a much smaller size. Then I will shrink the partition to match the size. Then I will move the whole partition to the end of the disk, and in its place I will create ZFS partitions that will contain the final file system and basically all of the data. For that, I first need to prepare some more things. So first, to prevent any interruptions, I need to remove a package that is commonly installed on virtual machines to be able for them to resize their hard drives. I don't want any interference now, so for that I'll just remove this package. Yes, I want to remove this package. It will regenerate the initrd image. However, now I want to prepare the partition layout for the other steps. So sfdisk -d, that will dump the partition layout in a machine readable format. Now I have calculated beforehand how this what the correct size should be. I want 4 gigabytes of space for the file system that I currently have. That should be sufficient. And it should even be sufficient if I install extra packages. So I will just replace the size here with a small script, so I don't have to type it again. So see, now it is replaced. Okay, so I can continue with my script. I will use a here doc again to basically, when the initrd gets generated, it should include some utilities that I will need later on. Some of these utilities should be already in the initrd, but I'm just making sure. So here is the here doc. I'm hitting enter now. Just beware that you have to escape some special characters, for instance, $. Okay. And another script that will ensure that on booting, all the resizing will be done before I boot into this system. So okay, so basically what happens here is that the partition gets resized, rather here, to 4 gigabytes. Then I basically take the size or the partition table, the changed partition table that I now changed just a step before. And I will basically create a new partition, move the partition to the back of the disk. So now I will do some additions to prevent Cloud Init from interfering with what I'm doing here. That will be just commenting out some stuff. So first I comment out in the etc cloud.cfg, I will comment out grow part and resize fs and disk setup lines. Okay, I'll do something similar for the Hetzner specific configuration files. And I can, of course, look at the file. So if I scroll back a bit, you see that these lines got commented out. It should not interfere with what I'm doing here. So now I need to regenerate the initrd image. That's what I will do. I could do it for a specific kernel, but here is only one, so I can do it for all. That will take a minute. In the meantime, I can actually check the image contains the binaries that I want. That is what I will do here. It will basically unpack the image and look at the files, and I have filtered out the lines that interest me. Now I will update the grub, the bootloader, just to make sure everything's included. Okay, and now I can reboot. So before I reboot, I will show you the partition layout again, and it should be much smaller when I get back. So, and we can ping the machine when it comes back online. We can continue with the installation. So while booting, it is doing the reconfiguration, resizing of the partition, etc. Ah, it's back online. So it seems we can SSH back in. And now the last command was fdisk -l, and see, just as configured, the partition is now much smaller. And it starts at the very back of or it is moved to the back of the disk. So what we can do now is we can clean up a bit so we don't do any resizing later on. That is what we'll do just now. So I remove the two scripts that I have added. They are now gone. Now I need to regenerate the initrd image. However, I should still leave some of the cloud init stuff commented out, so that is why I haven't changed it back. Okay. Now I need to install some extra packages for ZFS. Okay. It will also compile the kernel module, so that will take some time. That is what is currently happening. As you can see, the module wasn't found, so it is now going to be built. It takes a minute or two because the machine is not powerful enough. It has just 2 virtual cores and not much of RAM. However, that is enough. It just takes a little bit more time. Just show what happened beforehand. It went so quickly. I can show the graphs. It seems the CPU is quite busy, as you can see. However, in a minute, it should be all done. Nothing else is happening on the system. Okay, now it's all done. You can see that all the data got written, and now the CPU is idle. So we will continue with the installation. First, I need to find out which disk ID I'm actually configuring. That will be more deterministic, because def SDA, that is commonly used in the Linux land, can be problematic in some cases, so it is better to use these IDs. There is a number of them. I'm interested in this ID that maps to the complete partition. So I will use this ID and use it as a variable. So if I echo disk, that is all correct. Now we can continue. I can now create new partitions for ZFS. So first partition will be a small partition of just 2 gigabytes. That will be for the bootloader. Okay. And another partition for the file system, the root file system, and every other file system that I'll need. Now I will reread the partition table. Artx update disk. So now we should be able to see these partitions, and of course they are there. This one and the above. And ZFS is originally from Solaris operating system. That makes also sense. So now, before we actually initialize any of the partitions with ZFS, we can look, because we have basically created a partition in the same place that which was occupied by a different partition beforehand. So we should look if there is a file system that would possibly interfere. So we'll do just that. This command is just looking. And of course, there is still the EXT4 signature, which we will remove. And it's gone. We'll load the ZFS kernel module and initialize the pools. So the boot pool has some specialties. We need to enable specific features. Okay, that is created. We'll create the main pool, the root pool. That is all created now. And we can continue with creating some data sets. So that will be the root pool dataset. We'll do the same for the boot pool. This is all following the guide that I showed in the beginning. Okay. And now we'll mount root pool. So we can create a specific mount point of the boot pool because it is mounted under /boot. So first we need a root pool for slash, and then we can mount /boot in it. We'll create some more data sets. This is probably the recommended way. Okay, they are created now. If you were to create a Postgres database, I recommend to decrease the record size and perhaps configure compression in a different way or turn off the A-time. This could be a suitable configuration. For instance, you should think about decreasing the record size number to 8K, which is native to PostgreSQL, or 16K if you believe the compression will help you more, and you will basically avoid some of the write amplification just because of the compression. I'll do just that. And now I just prepare some directories, and in a moment we'll be able to copy the files from the current system into this system that we just prepared. That will take a minute. We'll do just that, exclude some directories, basically some virtual file systems, and we'll do just that. So again, large copy. As we can see, it utilizes the resources. We could, of course, now mount a virtual media, or we could use debootstrap to basically initialize Debian operating system inside our new ZFS partitions, but we are already on a running system that seems to be working perfectly fine, so we can just copy the files. Now we need to just mount some of these virtual file systems, and then we'll change root into this new file system that we have. Okay, so now we can see that basically the path changed. We are now inside the system that we are creating now, and I can just make sure that I still have the variable at hand, and I do. So now I can install some more ZFS packages. That's what I will do. And I want to reinitialize the init-rd later on. Okay, now I will clean up my EXT4 tab because I will not have any EXT4 file system, so I'll just comment out the line that contains the EXT4. I can make sure that is what actually happened. And sure enough, here's the line containing EXT4, and now it's commented out. So I will install a systemd service, continue with my favorite HereDoc approach, and I need to, I just can look at it, so make sure that it's actually there. Yes, everything seems to be all right. So I can enable the service. Okay, I can make sure the TMP file system will be created. So that is another approach. Now I need to test that we have ZFS support in our bootloader. That is what I will do. And sure enough, there is ZFS. So I will regenerate the init.rd in this context. And it will not support crypt setup. That will, the compilation will just scream about that. But that is expected. And the last few steps, I will change etc default grub to contain some changes. I will extend the grub command line Linux to include a hint that the root file system is on rpool root Debian. And I will decrease the timeout, the grub timeout. So we don't wait for 5 seconds, but just 2. It should still enable us to fix some stuff if we must, but it will just save 3 seconds on boot. And just to confirm, I can look at the file. So here is the grub timeout, here's the grub command line, and grub terminal is console, that is uncommented, so everything is fine. So now I should run update grub. And we can install grub just to make sure. Yes, it's all there. Now we will fix some mount ordering. Okay, I hit enter another time, and I can verify that actually my caches are full, and that seems to be the case. So I can now foreground the Z process, the ZFS daemon, and I will stop it by hitting Ctrl+C. So I will fix these paths to remove the mount prefix, basically. So if I look at them again, they should be fixed now. Yes, that is the case. And now I will make ZFS snapshots for the rpool and the boot pool. As you can see, that is very quick. And exit from the root environment. So now I will unmount some of the stuff that we have mounted previously for ZFS, and then I will export the pool. That might fail. In that case, it should still be fine to just reboot. If there are some other problems, please refer to the guide. So we'll do just that. We'll reboot now and hope for the best. So again, we'll wait for the system to get back online. Can look at the graph to the side. And yes, so we can log in and check. Okay, so the system booted. We can look at our pools and data sets. It all seems fine. Now we can take care of the little partition that we don't need, the ext space we can reuse. So we'll do just that. We need to define our disk again. So disk alt dot include this. Okay, echo disk just to confirm. Yes, that seems to be correct. And I will delete the disk. So if I just rescan now, all right. We need, I messed up. I need to write 1 in the end here. Yes, it seems I have removed the whole partition table. That is, of course, not what I wanted. So what can we do about it now? Not much, I guess. We can, however,